Okay, right. So we're given a vertex. Let's use vertex form. So vertex form is y equals a times x minus h, quantity squared, plus k. Okay? In this scenario, what is our h? 1, right? It's the x-coordinate vertex there. So we'll have y equals, I don't know what a is, so I'm going to hold off on that just yet. Okay? We'll have x minus 1 squared plus, and what's our k? Negative 2, right. So I should really put a minus 2 there. I can just make it plus negative 2. That's fine as well. Okay? So, what is our a? Or how can we find it? So what is a in this problem? What does it end up being? 1, right? But a lot of us got that right because we assumed that a was 1. It didn't have to be 1. Right? A could be negative, A could be positive. In fact, you learned that in step 2 that A did not have to be 1. How can we check to see that our A is in fact 1 here? We did not use this point yet. How could I use this point to help us here, though? Go ahead, Paige. Yeah, plug it in, right? 3 would plug in for what? X. And 2 would plug in for Y. Right? Those are X and Y coordinates. They're not h and k because they're not a vertex. It's just random x and y's. So I'm going to plug 2 in for my y, and I'll plug 3 in for my x. Okay, and then we're just going to solve for a. Okay, we'll just solve for a. So I'm going to add the 2 over, so I'll get 4. And then 3 minus 1 is 2. Squared is 4, so I have a times 4. And divide both sides by 4, we get a is 1. So you guys were right? I mean, it is 1. But now we are right for the right reason. Okay? Not just because we assumed it to be true, because it's actually true. Okay, so there's our equation. All right, questions on any of that? All right, yes, Ash.
It's not exactly on that, but for the slope formula, is it y1 minus y2 over, or is it plus?
Minus. Mm-hmm. But my hesitation with that, no, okay, yeah, I think you potentially could be using that, yeah, okay, yeah, all right, I'll hold on. All right, number 2. Another situation that I gave you guys, the next scenario that I gave you was we had given 2 zeros and a point. And there's a couple options I saw here. I guess there was kind of a couple options with the vertex too, although I really thought the vertex one was the best. But there were a couple options I saw here. Okay, so one option here for this next situation, the 2 zeros, sorry, we're -1 0 in this case, and 4 0. And the point here was 3 2, again, okay. What would be a good form to use here? Yeah, intercept form, right? Because we know the intercepts, okay? So in this case, it'll be y equals a times x minus, and then you can pick whichever one of these you want to be p. I'll just let the -1, so x minus -1 times, and then for q, then that makes x minus 4, right? So if I simplify that a little bit more, a x plus 1, x minus 4, okay. But again, we run into a problem, right? Because we don't know what a is. How can we find a? True. Plug it in, right? Plug in this other point, 3 2. 2 is a y coordinate. It's got to work in the equation here. So, and then 3 is our x coordinate. Okay. 3 plus 1, 4. 3 minus 4, -1. So this would be -4. So 2 is equal to a times -4. We'll divide both sides by -4. We get a is -1/2. Okay, and so we get y equals -1/2 x plus 1 x minus 4 there. Okay. Some of you guys, when you first graphed this to kind of check your work, you looked at just the x plus 1 times x minus 4 thing, right? So you kind of assumed, you're like, Mr. Wade, maybe a was 1 again. So I'm just going to put in the x plus 1, x minus 4. I'll just put in the 2 zeros, and let's see our table here, right? And if we go to our table at the point at 3, you can see at 3, you get the y value of -4. Okay? But we don't want the y value of negative 4. What y value did we want? At 3, we wanted what y value here? 2. Okay? We have negative 4. But what could you do to negative 4 to make it 2? What could you multiply by? Negative 1/2, which is the a value that we end up getting there. Okay? So you can kind of like correct that. You can kind of correct what you get, right? So here we had no a value, right? You can kind of then correct that the y value here by figuring out what you would multiply negative 4 by to get the desired 2. And if you multiply the negative 1/2, you'll get what you want, right? So then we just need the a to be negative 1/2. Because that's what we're multiplying by there. Okay, that's another way to do it. I think I saw some other folks. So like Tessa, you found the x coordinate of the vertex here, right? But then you kind of got stuck because you weren't able to find like the y coordinate of the vertex and stuff. So right, Tessa used symmetry here. Okay, she knew that negative 1 and 4 they're going to be equidistant from that axis of symmetry. So she added those two together and divided by 2 to get the x coordinate. But then she had some trouble with finding the y coordinate of the vertex. So she wasn't quite able to use vertex form there. But that was a good strategy or good thinking there. Something we have done in the past, right? Any other strategies there you guys want to share? All right, and then number 3, the last one here. Okay. This one is just 3 generic points in the quadratic, or 3 points. We don't know if they're the vertex. We don't know if they're zeros. Well, in fact, we know they're not zeros because of their coordinates. Okay. So in this case, we had negative 1, negative 3, 0, negative 4, and 2, 6. Okay. So vertex form isn't going to be super helpful. We don't know the vertex. Intercept form is also not going to be super helpful. We don't know the intercepts, the y or the x-intercept. We know the y-intercept, we don't know the x-intercepts. So those are both kind of out. So that'll be standard form here. So how are we going to use standard form? Well, standard form, I can plug this in. So again, standard form is ax squared plus bx plus c, y equals, sorry. And then I also have, I'm going to write it out 3 times here. I'll show you what we're going to do. Okay, so for this standard form, I'm going to use this point. Okay, where can I plug this negative 1 into my standard form? Where can this negative 1 go in my standard form here? For what variable? X. And that negative 3 will go in for what variable? Y. So I'll have negative 3 equals a times negative 1 squared plus b times negative 1 plus c. Right? Mr. Wood, that does not look very helpful. I see 3 variables. We cannot solve an equation for 3 variables. Well, we're not done yet. I'll do the same thing here with the other point. So I'll put negative 4 in for the y, 0 in for the x, okay, and plus c like that. And I'll do the same thing here for this equation using this point right here. Okay, so 6 in for the y, 2 in for the x, and like so. Now let's do some simplification, right? If I simplify here, I'll end with negative 3 equals, let's see, negative 1 squared is just going to be a plus negative b plus c. Here, ooh, this is really nice. What happens with a and b in our second equation here? They go away. So we get negative 4 is equal to c. Ooh, that's nice. Let's see what we get here. 6 equals 4a plus 2b plus c. Okay, so we've got c. Hooray! But we don't have a or b. But now that I know that c is -4, what can I do over here? Yeah, sub it in, right? Plug it in. Yep. So we got -3 equals a plus -b minus 4. And over here I'll have 6 equals 4a plus 2b minus 4. Like that. And then I can add this 4 over, I can add this 4 over. So I'll end up with 1 equals a minus b. And here if I add the 4 over, I'll have 10 equals 4a plus 2b. We still have 2 variables here. But we have 2 equations. 2 equations with 2 variables. How can we figure out what a and b are going to be here? Max?
So you want to move the a, let's say the 10 equals 4a plus 2b.
Okay.
You move the a over by itself, and the 10 over towards the 2b.
Okay, so you want me to move the 4a over here, the 10 over to here?
Yes.
Okay, so you want to solve for a, in other words, right?
Yeah.
Gotcha. Okay, so we'll have -4a equals 2b minus 10. Tim, is this where you were going to kind of go to? Yeah. Yep, substitution. Yep, that's what we're going to do.
Yeah.
Yep. And then, so you divide everything by -4 over here?
Yeah.
Okay, so, oof, we're going to get some yucky fractions, but that's okay.
Probably would have been better to do.
Yeah, that's okay. We'll do it this. In fact, you know what? Let's do it the other way. Let's just, because it'll be easier this way. Let's just solve for a over here. Much easier. We'll just add the b over. So we'll have a equals 1 plus b. Then we will take this a equal 1 plus b and we will sub it in here for this a. 4 times 1 plus b plus 2b. You guys remember systems of equations? Yeah. Yes? So yeah, kind of, yeah. Plus 4b plus 2b. So I get 6b here. I'll subtract 4. I get 6 equals 6b, so b is 1. Now that I know that b is 1, what does a have to be? 2. And so our final answer here is y equals 2x squared plus 1x plus -4. If you think that's bad, I did not show you the toughest one yet. Go ahead. Finish.
10 equals 4a plus 2b. Could you divide the whole thing by 2 and then say basically 5 divided by 2? What can fit into 5 twice and then have one thing left over?
Yes, you can use other strategies here. So for example, I think you're kind of getting into the idea of elimination. So let me do that on the side here maybe. Okay, so first of all, let me just make sure, are there any questions on this process? Okay, so we were greatly helped out by the fact that C we were able to get, right, by the fact that we had the y-intercept here. The zeros cancel out the a and the b to give us the c. Imagine if we had had a point here such that the a and the b did not cancel out. And imagine if we had a's, b's, and c's, a's, b's, and c's, a's, b's, and c's. We can still solve that. It's pretty awful. All right, but we're going to hold off on that maybe for right now. Okay. I will say, though, that the review question is like that. Anyway, let's go back to Ash's question here real quick. So, yeah, this equation right here. So, essentially what we have is this. 10 equals a minus b, 1 equals a minus b, 10 equals 4a plus 2b. So, yeah, we could change this to be, dividing by 2, we get 5 equals 2a plus b. And we have 1 equals a minus b. Another strategy that you have for solving systems is that you can use elimination by adding the two equations together, right? The negative b and the b will cancel, and so you get 6 equals 3a, and so you get a equals 2 that way. And then you can get the b using the same kind of method. Okay? So that's kind of along the lines of what you were going to do, I think? You were kind of trying to figure out, based off of this, how to get 5 maybe? Yeah. And so twice what plus what would give you 5. So yes, the problem is if I gave you fraction answers for A, like A or B were fractions, right, then you'd be stuck because you'd have a lot more options there, right? But in this case, you guys kind of guessed that this one was going to be nice and not give you awful fractions or something. So it worked out that way, yes, but it doesn't have to. And that's why you really want to use either the elimination or substitution. Okay? Sure. Okay. So I think at the time remaining, I'm going to show you an awful one. Okay? Because I think we need to see it. Okay? So here we go. And I hope I have enough time. Mr. We've got 15 minutes. Are you serious? I am kind of serious. Okay, so here we go. We'll see. All right, we will see. Goodness, do I want to? All right, let me make sure that this is going to be okay here. -1 for x, 0. Yeah, okay, this will be good. All right, so we're going to do one more here, and I'm just going to show you this awful one, okay? I will already give you the heads up. Let me just check to make sure that I am right about this. Okay. I'll hold off on what I'm going to say until later. Secrets, Mr. Okay, so 3 points again, but new 3 points. -1, 0, 1, -2, 2, -15. Okay, I will hold on what I'm going to say. I have two things to say, actually. Maya knows one of them, but she doesn't know the other one. So, all right. Okay, so here we go. Ready? This is going to be so exciting. So again, we're going to plug all three of these into standard form. So we get 0 equals a times -1 squared plus b times -1 plus c. And we'll plug in this one right here. -2 equals a times 1 squared plus b times 1 plus c. And we'll plug in this equation where we get -15 equals a times 2 squared b times 2 plus c. Okay, and I'll simplify here. We'll get 0 equals a plus -b plus c. Okay, -1 squared is 1. -1 times b is -b. Okay, here we'll have -2 equals a plus b plus c. And here we'll have -15 equals 4a plus 2b plus c. Okay, so far so good?
Yeah.
Question? Sure. It'll be on the video, but you can watch the video if you want to. You know, spoilers and stuff like that. All right, so anyway. What's the problem here? Yeah. Yeah, we did not eliminate any of our variables here. ABC, ABC, ABC. Okay, nothing eliminated. Womp, womp. Okay, so we have to use a combination of like elimination or substitution so we can cancel some variables out. Okay, we want to use a combination of elimination or substitution to cancel variables out so we can get down just to one variable. Does anyone see a combination of these three equations with one another that will get two of them to cancel out? You might have to multiply by a number to make them cancel out. Okay, so right here, Claire, you're right. If we were to add these two equations together, we would get the b's to cancel. We would still have, though, a's and c's left over. Okay. Now, so Claire's on the right track there, but you'll notice that the a's and the c's are the same sign. What if I took these two equations here? So I'll take the 0 equals a plus -b plus c, and I'll put the -2 equals a plus b plus c. So Claire was saying if we add them up, the b's will cancel. And she's right, and that might be a good strategy to use here. Okay, but I see a little bit better one we could do if we, let's multiply this bottom equation by -1 on both sides. If I multiply both sides by -1, I'll have a -a and a -c, which will cancel out the a and the c simultaneously. You see that? If I multiply by -1 here, the a's and c's will cancel out those a's and c's. And so we end up with 0 equals a plus b plus c. And we get 2 equals negative a plus negative b plus negative c. Oh, positive b now, sorry. Nope, I messed up. Darn it. Sorry. 2 equals negative a plus negative b plus negative c. Okay. This should be a negative b right here. That's what I missed. Was a negative b. See? It's so easy. So easy now. Okay. So again, we took these two equations. I wanted you to see here that these a's and c's, we can get them to cancel out by adding them together if I make these opposites. So I took this equation here and I made them opposite by multiplying both sides by -1. So now when I add these two together, it'll be 0 plus 2, which is 2. A plus negative a, what happens? Cancels, right? Negative b plus negative b? Negative 2b. C plus negative c? C plus negative c? Cancels. So we're able to solve for b here. So we can divide both sides by -2. Question, Slayman?
Why can't you just add them together?
So because they're equations, right? And when I add something on one side of the equation, I can balance it out by adding the same thing on the other side, right? So in this particular problem, we are told that -2 is equal to a plus b plus c, right? And we're told in this problem that 0 is equal to a plus negative b plus c in this problem, right? So I have this equation. Okay? If I add, and again, I took this equation, I multiplied both sides by -1, so I got this one right here. So far, so good, right? If I add 2 to the left-hand side of this equation, I could add a 2 to this side if I wanted to balance it out, right? Add 2, add 2. But I know if I add 2 here, that's equivalent to adding a negative a and a negative b plus a negative c, because we know that they're equal to each other. So they cancel out. Does that make sense? That's how we're able to add that, like that. Okay? So we get b equals -1. Okay, once we have that b is -1, now I can rewrite all of these equations here so that b is -1. So I'll do that right down here maybe. So I have 0 equals a plus -1 plus c. -2 equals a plus -1 plus c. And -15 equals 4a plus 2 times -1 plus c. Okay? And then I can simplify. So that becomes +1, but I'm going to subtract it over, so we will have -1 equals a plus c. This is a -1. I'll add it over, so we'll have -1 equals a plus c. Well, that's not super helpful. They're the same. Hopefully this one doesn't do that. -2, subtract it over, -17 equals 4a plus c. Whoops, I added it wrong. It should be -13. Because it's a -2, I'm going to add it over, so it becomes -13. Sorry about that. All right, and now we only have 2 variables, and so we can use elimination or substitution again, whichever one you want. You could solve this one for A or C, solve this one for A or C, and plug it in here. I'm going to use elimination again, though, so I'm going to put underneath like that. And then to get opposites, I'll multiply... you know what? I'm going to multiply this bottom equation by -1 to get the c's to cancel out. So I'll multiply both sides by -1. And so we end up with -13 equals 4a plus c. And then -1 times -1 is +1. And -a plus -c. Okay. So our equations, the c's will cancel. We'll have a -12 equals 4a minus a is 3a. So a will be -4. So we have our a and our b. And then I can find c here by just taking my a of -4 and plugging it in. Okay, add 4 to both sides. We get 3 equals c. Okay, it's only half a sheet of paper. That's pretty good. And I didn't use all my space, really. So I mean, it's not really even half a sheet of paper, but it's pretty close. So our final answer is y equals -4x squared minus 1x plus 3. Okay. Okay. Now, Are you ready to hear Maya's secret? Okay, here we go. All right, so you have your graphing calculator ready?
Yep.
All right, so get your graphing calculator handy. Okay, and there's a couple ways to use graphing calculator here. I'm going to show you like the one that probably makes, well, yeah, whatever. I'll show you I'll show you one way to do it with your graphing. There's a couple ways to do it with the graphing calculator, but anyway, here we go. Ready? All right, in your graphing calculator, press Stat, Edit. Clear out your L1 and your L2. Okay, we're going to use our statistics here. Okay, and we're going to type these 3 points in. So the x coordinates in the L1, the matching y coordinates in the L2. Okay, x coordinates in the L1, matching y coordinates in the L2. Right, that's just from our points there. -1, 0, 1, -2, 2, -15.
How do you get to that page?
Stat, edit. Stat, edit. Okay. Then you're going to press the Stat button. And you're going to arrow over to Calculate. And you're going to go down to Quadratic regression. You're going to hit Enter. And you're going to hit Enter again. And A is -4, B is -1, and C is 3. Okay. That's one way to do it. Okay, that's one way to do it with the graphing calculator when you have 3 points like that. Okay. Stat edit. Type in your points in the list, in the table. Okay. Then stat calc, and you go down to quad reg. You've done this before in Algebra 1. Okay, I know you've done it before in Algebra 1. Maybe not with 3 points, you do it with a bunch of data, but this is another way to use that calculator in a way that's maybe not intended. Okay? Question? Stat edit L1 and L2. Okay? So your coordinates go in like a table. Okay? Let me give the homework to you real quick. Homework! Homework. Green book.
Are you posting this on
It will be posted on Schoology, yes. Green book 4.10. Page 312. Numbers 12. 23. And 31. I never went over the homework. I'll do that on Monday. I never went over the homework, did I? I did. I never went over the homework. I'll do that on Monday. I'm sorry about that.
Are there going to be any,
Actually, I went once.
There's one of each type.
do we have a word problem on our test? Is that going to be weird numbers?
It's calculator active, so it could be, but you have your calculator. All right, 3 problems for homework.